Thank you, everybody. I'm really glad to be here. But before anything, actually, I would like to say thank you for all the people being here, also being people from Voltron Data and Pandas maintainers who also happen to be here. So don't be too hard on me. Also, thank you for developing these amazing products that I get to talk about in these talks. Another caveat, since there are people here, the title is clickbait, okay? You should know it by now, okay? Like me, I mean, come on, guys, yesterday... Yesterday, I gave a talk stating that Rust was easy, so, okay, you should expect it by now, it's in the character. So, but still, today, I would like to talk to you about polars and asking once again, for the next time, for the hopefully one last time, whether this is the end for the great data frame showdown. My name is Luca. I'm a machine learning engineer at Futura, and I'm also an organizer at Python Milano. And I would like to start by asking for you, everybody among us, to raise our hands, and then start progressively going down if we do not meet the same criteria. It's like ever, right? Okay, but not with no alcohol because we comply with the cock. So pull down your hand. Okay, how many of us had to do explanatory work? Mostly. Okay, good to know. It would be weird, right? If you weren't here for this. How many of you had to work with lots of raw or unstructured data, such as JSON files, NoSQL databases? Okay, many hands to raise. Good, good. How many of you had to do it on a small machine? I'm talking for you through a MacBook Air without gigabytes of RAM, so that's okay, but maybe not so much.
How many years ago are you asking?
Doesn't matter. Without the time or budget or the knowledge, to use like, I don't know, Apache Spark, for example, still like more than half of your hands. That's good. That's where I found myself in the past like 2 to 3 months because I'm working on a huge dump of unstructured data, like JSON line data from that I got from like a DynamoDB, which is a which is the AWS NoSQL database. And working through it is a pain, but it's also a pleasure, actually, because you have outstanding tools to do so. But sometimes performance comes at a little price, especially when you have to work with, I don't know, 2 gigabytes of compressed JSON turns out to be 15 gigabytes when you uncompress it. And so this machine doesn't work with it, okay? Pandas can only take you so far, and it's still quite a lot. But still, this makes us ask the question, is there something new we can do? And this was like a never-ending question since at least 2008, I guess. But today we have amazing tools to work with that, and I'm going to talk to you about polars. So today I'm going to discuss a couple of points. The first one being, wow, we released Pandas 2.0 like a couple of months ago. Congratulations, because it was an outstanding achievement that made Pandas like more compatible with the so-called Apache Arrow ecosystem. And this begs the question, right? Okay, Pandas 2.0 was coming, so why should I use polars? I'm going to try to answer these questions. I'm going to also try to tackle the question, you know, my Pandas data frame pipelines work just fine. Why should I rewrite the code? Also, it will take time to convert code from Pandas to polars, so why should I bother? And of course, if it ain't broke, don't fix it. But still, I would try to show you that you can take your Pandas workflow and effortlessly translate it into a polars workflow. And then if there is time left, I would like to show you a couple of tips and tricks and quacks to make a spoiler for people like aware of this in the context and see where polars is right now and what it needs to grow. So let's get started. With Pandas 2.0, we can use the PyArrow data type backend to enjoy a couple of really sweet features. For example, a more compact memory representation. Pandas was already using Arrow data types, for example, for their string array type, which makes it much more performant than it was all before, because of course, relying on NumPy, we had to use objects. Objects were just like array of pointers to Python objects, and Python objects are quite big. The empty string was around like 200 bytes before people of the faster CPython project started to work on it. But still, that is maybe not enough. So this is the answer to the question. Can Pandas 2.0 replace polars? Unfortunately, it can't, because even when it is using Arrow at its backend and leveraging Arrow Acero compute engine, it actually is not using Arrow compute for all of the operations on Arrow data types. For example, and people will correct me if I'm wrong, but I had fact-checked this. Group by operation do not support PyArrow compute. So we're still using the old block manager, and we can just like go down the sink with performance. So most, I would say some at least, operations are still single-threaded and unoptimized, whereas polars can offer you all cores by default turned on your machine, as PyArrow does, optimized queries with a lot of sweet features such as predicate pushdown and filter and optimization of all the like SIMD, single instruction multiple data operations. Also, polars though, and it's something that as far as actually PyArrow can also do, some way, is working with data larger than memory. So for example, I could be streaming, processing like 200 gigabytes of data of a Parquet file, for example, through this tiny bit laptop using polars. And also, one of the great things that PyArrow and polars also share is working with nested data types, making it a breeze to work with them. And so, yeah, you know, these are the reasons why you might be interested in using polars when you find that using PyArrow or the new dtype backend for Pandas is not enough. And so let's move on to the next phase. How long does it take to pick up the polars syntax? And since we're doing a bit of Python, let me just get my attire. Okay, now we're doing Python. Okay, we're not doing Rust today. But before that, for a couple more references to compare to what I'm going to tell you, you should watch back the talk that Alessandro Molina gave yesterday on Apache Arrow. You should be watching the performance comparison that Alberto Danese made on Rust, actually polars and other data frame libraries. And also stay tuned because right after this, actually 2 talks after this one, in this very same room, Fabio Riferi from Extreme will tell you how to push Pandas performance to the limits and optimize your pipelines. Okay, rewriting Pandas code with polars is actually easy. We can do it from the import, we can do it from the reading. You see, basically, read CSV, polars also has read CSV, read Parquet. It has read ND-JSON as well. Writing starts to diverge because you do not write to a format, but you write a format. And so far, so good. But polars has something more. Polars can also scan data types. This operation, and we will see it a bit later, returns a lazy frame. It is not a data frame that is read into memory, but is a data frame that, like, it's a memory mapping of the data underneath. It works both with Parquet files and CSV files as well, but I do not recommend you using CSV file anymore, sorry. It can also read globs of Parquet file. Pandas, of course, does already that. But if you scan them, you get sort of a memory map of like a file-like structure that contains Parquet file that match your regex pattern, for example, your glob pattern. And then if you process it through your ETL function, then you can sync the data. So basically, the kind of operation that polars will do is understanding that it is huge hierarchy of files somewhere in your S3 system, for example. You can also read from S3, of course. And we'll process the data bit by bit in a stream, so data bit by bit, chunk by chunk, and then append every result of this operation to a single individual Parquet file, for example. So if you have a batch job, or if you just look streaming data from a database to, I don't know, an S3 lake, then you can have an S3 data lake or any other sort of data lake. Then you can, at the end of the day, for example, do a batch job that you can scan all of these files and then sync them into an individual one. What about other formats? Of course, polars cannot read data, cannot read SPSS. Why should it? Why should we ever, actually? Sorry for the bashing, okay? We can use Pandas for that, because so long as the memory conversion, actually the cost of converting a Pandas object into a polars object is quite low, especially when we're using a data type such as the data type backend such as PyArrows. So we can read anything from Pandas, and using from Pandas, we can build a polars data frame. All of these operations require PyArrow to be installed in your system because under the hood, it's all PyArrow magic. Then comes the APIs. And people that have used PySpark, not me, will know it. We feel like it is much similar. And in a way, it might be more expressive than Pandas, controversial take, but I get that Pandas like has a long tradition, so you cannot break stuff. Polars can break stuff and will break stuff quite often. We see like 0.17.4, so there is a lot of room for breaking changes. And one thing that we love pandas for is like its reliability. So here we go. But still, column selection can be performed in this following in many ways, actually. We can just use column names inside this select function. These functions, select, and we will see many others, filter, group by, they all serve the purpose to create a context. Contexts are filled with expressions. Expressions operate on the data. Context, and they cannot be used alone. So we always have to be working in a context. This is because inside the context, Polars actually performs all of the optimizations. We can select columns like so like using list of strings, iterable, couple of strings, tuples of strings, etc. as arguments. We can also use the pl.call selector, which works in the same way, but can be enriched, for example, to use select columns by data type, select column based on a regex pattern, or we can use select all to get all the columns, and exclude some based on all the patterns that we saw above. So we can select all column except the data type, blah, 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 blah. And then by piping and actually by method chaining, we can use these select contents and these pl.all.exclude to perform operations on this data. And here we are. For example, I see this quite likely structure that I've been working on. Polars code tends to be verbose, especially if you like method chaining and if you like just parentheses everywhere. Sorry in advance for people noticing that I'm using like a 2-space indent because I would like to fit the content on the screen. And as we see here, we have a couple of things going on. We see a new context manager called filter. We see a new context called filter, a new context called with columns that creates new columns on your data. And let's see them, for example. This with columns context contains all the new columns that we want to create. And see here, for example, that we can work with dates in a very similar fashion to what we've been used to with pandas. So we use pandas.series.datetime.doanything. We have the same structure with polars. So we can see for both columns start and end, we can use the t.day and extract the day and add a suffix to this column, for example, to both of them. So the output of this function would be like a column called start day, end day, for example. Doing this with pandas is fine because we have a great .assign method that allows us to work with this, though it requires working with lambdas, and so in general it's fine, maybe it's just a matter of personal preference. But we will see where polars will shine in terms of syntax, just right after this. We can also perform typecasting, and we can just give aliases, like give new names to your columns, and we can do something like we can work with strings, as we used to with pandas, but we can also work, and we have a specified syntax, a specific syntax for arrays, and mappings, which means like structs, dictionaries. And this is great because you can do like something like this in pandas and in polars. This will return, this will return a structure, a list of 2 elements. For example, you suppose that the name is like a name space name. We can use polars.3.split with the space and fetch the first element of the array and give it the name first name. And then we can fetch the last element of the array and give it the name to this column given last name. Of course, the array methods are much more than this. It's just like a broad overview. But still, you have a specific namespace for arrays, and so you do for structs, to extract field from structs. The difference between structs and arrays being that arrays are lists, structs are actually data types like nested that you have, like, for example, a map. So you have a schema for them. So you can have like you can read the JSON file that has nested folders in it. Polars will do its best, PyArrow will do its best to read it with a structure, a predictable structure, and you can fetch items from that structure underneath. You can also do filtering, and filtering is neat. It is done with this filter context, and you can do easy stuff like filtering all the values where, I don't know, the string is equal to some string, but you can also do window functions, for example. You see that pl.count will count the number of rows, for example, over, this over keyword actually uses and enables you to use rolling functions, such as like in the old SQL. And this is great because you create this column on the fly and you only filter the values. You don't have to create a new one. You can also do group bys, and this is where things get crazy, and this is where actually Polars shines. We can group by. This creates a context, much like in pandas, like the syntax is very similar. We can use .ag, which is the same as in Pandas, but while in Pandas you have to pass through a dictionary of strings and functions, or strings if the function is like a mean, you can be more creative with polars. For example, here we're grouping by 2 columns, and we want to apply the mean functions to both of them and append to both of them the suffix mean. In this other case, we want to get this column called a student unique identifier, fetch the unique number of identifiers of the students, shrink the dtype, because we can go down from, I don't know, integer 32 to integer 8 to unsigned integer. Polars will perform this conversion and give it a new name. Or in this other case, we just get the first value, the first occurrence of these other 2 columns. And this also works for temporal group bys, called like upsampling and downsampling, much like in Pandas, where we have the resample function, we have an analog function in polars. We can also do much more than this. Polars contains functions to show the optimized or unoptimized graph of the operation it is going to perform, because basically under polars there is like an engine, a query engine, that builds a query plan, so optimizes the operation that you have to do to manipulate data. Pandas works only in eager mode, so operation happens sequentially. In polars, so you have to be particularly cautious of the order of the method that you call on a Pandas data frame, because otherwise you might be doing involuntarily some unoptimal operations. If you do polars, polars will say compile a plan and make it more even faster for you. You can also use the .profile method that will return a tuple of data frames. The first one being the result of your operation, the other one being a data frame containing the time that it took to perform each step. You can also plot this query plan, the performance profile, to see how fast or slow it was and where you should be looking at to increase performance, for example. And this is all native in polars. There we go. Another thing, using lazy frames. As I was telling you, Pandas only works in eager mode. Polars also works in a so-called lazy mode. And this is the great feature of polars. You can be exploring data in eager mode and then seamlessly cast anything into lazy mode to perform the most compute-heavy operations, for example. And put those on, I don't know, a virtual machine with 190 gigabytes of RAM, and run that operation as your ETL pipeline. I'm sorry, PySpark people, but I mean, if you do not have the knowledge, the expertise to manage such a huge resource such as a distributed system, you can use polars for this. And the great point of this is that it makes the ceiling for adopting PySpark or another distributed system much higher. So this is another great feature to keep costs down, for example. Unless one day we make polars like distributed, I don't know. We will see like the old Dutchman will do. The data frame, the lazy frame syntax, actually any reading function that is uses scan will return a lazy frame, but you can cast any data frame into a lazy frame by calling the .lazy method. Does the syntax changing for working with Pandas data type, for polars data types and data frames when you use a lazy frame? Absolutely not. What changes in the end is that if you want to fetch the result of the operation on a lazy frame, you just have to call .collect at the end, or you can sync the results to a Parquet file, for example. So this will mean that it will never have to read the whole data into memory. It will just read bit by bit the pieces that it needs and then flush them into a Parquet file. Other things, we all know DuckDB. It's a wonderful framework. I wouldn't call it polars on C++, but you get the gist of it. They claim to be the new SQLite for data analytics, and they're a wonderful framework. They allow you to use a lot of old SQL, or Squeal. I think this is called, that's the name of the language. I don't know it very well. I think it's called Squeal. You can use Squeal syntax on working with data frames. You can do that with polars as well. Since fairly recently, I would have to say. There are some limitations, but you can use a SQL context to, I don't know, read existing Python data frames or like polars data frames or lazy frames into the context, and then use the context, for example, to query your dataset. For example, here we're reading a data frame using read CSV. If it was big, you could use those like scan CSV. And then we can register in the context all these objects, globally, for example, basically what will happen is that all data frame objects will be read into the SQL context and will be available basically as tables for you to use. You can create tables, but actually it's easier to return data frame object and then start working on them. And we can switch on and off between lazy and eager execution inside the SQL context as well. And there we go. You can use SQL on a Python, inside your Python script. Maybe you're more familiar. Maybe you have somebody else using that. Maybe you're just working with your data analyst and they don't have the time to dig into the nits and bits of polars. They can also use this solution as well. Finally, polars can also quack, squeal from the command line. This is a bit hardcore, okay, bleeding edge, really. For those who really want to bleed, we can build from source, like clone the repo, cargo build, whatever. Sorry, you have to use a bit of Rust for that. Sorry, it was not like 100% Rust-free, but I captured it. And then we can call polars, and this will basically spawn a CLI, like a REPL, where you can call SQL, basically, and a bit of polars function, let's call it in this way, to work with your data from your CLI using SQL syntax, for example. That's basically the same thing that DuckDB does, but like DuckDB at first was really well known for this, and Polar like basically closed the gap with this. I wouldn't call them interchangeable right now because they have different statuses, especially with respect to Apache Arrow, but still, it's good to have them. So you do not have to juggle between both of them, for example, if you prefer one over the other. And you see that as a result of the operation, you get nicely ASCII formatted tables, which are nicest to read, and also you see that report the data type of the objects. And you see here, for example, that the calories column is an integer of 64 bits, then we can also use it like a more compact structure, calling, for example, shrink data type, and make this an unsigned integer of, I don't know, 16 bits, because we expect it to be this be greater than 0. And we can also just use echo and like bash scripts and use the pipe operator to flush everything into polars and have polars return the same result. I would guess that this is pretty much the end for what I wanted to tell you. So I'm open to questions. Please don't be too rude. I hope I can answer your question. I think I will put down my scepter and ready to answer all of your curiosities about polars.
Yes, we have several questions. Is there a performance benchmark between Pandas and Polar?
Yes, there is. It is called, so DuckDB took back the old H2O.ai database, data frame performance query, blah, blah, benchmark, and they're running it, and it takes like quite a long to run, but they have updated results up until the latest minor version of Polar, which is like 16 point something. We're now in the 17 point something. And so you can see a compared performance of DuckDB, Polar, PyArrow, and a lot of data frames. But if you want to look to more like down on earth comparison, you can watch back Alberto Danese's talk of yesterday's on this. To my personal experience and some other people that are using Polars in production, there is. And it's huge. And I personally found myself extremely useful when you have to stream through datasets. I can just, I myself found out that I couldn't read a nested JSON line file with polars because there are some things that the expectation from the data structure that are not met. I can use Pandas with its chunk JSON reader, so which basically you read the JSON, but you can return like chunks of JSON at a time. I read those with Pandas, transform them immediately into polars after a small ETL to get the columns that I need, and then I perform the heavy lifting with polars and sync everything into an individual table. And this is really great in terms of performance because I/O happens on a multi-processing level, and all the others operations do as well.
Thank you. Concerning pl.scan functions,
yes.
Do you know about plans to add the scan SQL function as well? As far as I know, so far there is only read SQL function, unfortunately.
Yes, I agree. As far as I know, Polars does not have a scan SQL, for example, or scan database. So the point is, if you just do read SQL and then add a SQL query, and then pass a connection object, the whole data resulting from the query will be loaded into memory. So if reading a huge database, you have to be cautious about that. There is no option currently to scan a database.
Thank you. When creating expressions, I saw a number of attributes like call.r
Yes,
struct.
yes.
Can you elaborate on their role?
Yes, basically, as in Pandas, all the functions that work on arrays, structs, strings, and datetime objects are collected under an individual namespace, just for make them easier to use, easier to read, the documentation easier to find. These DT bits, from a like I would say, practical point of view, only serve the purpose to say, okay, if you're calling dt dot something, it's a function that works on datetime objects. If you're working with strings, it's like this, okay? You can add string.replace, string.split, string. I don't know, rpartition, strip white characters, and all the stuff like that. It's basically a way for expression, both in polars and pandas, to denote that they work on that specific data structure, that being data types, lists, datetime objects, strings, lists, etc.
Thank you. I see you can use lazy eval on Polar's df dataframe.
Yes.
From Pandas dataframe. Will this limit the data size to the size of memory, or there is a smart way of avoiding the constraint?
No. If you turn something into a lazy object, that object already exists into memory, so no performance, as far as I know, no performance, no optimization on memory consumption is made. If you are converting a Pandas data frame that uses NumPy as backend, it will automatically perform the conversion to PyArrow-backed arrays. So you will ideally get some performance gains because you have a smaller data structure, but that object already exists as a data frame, so casting it into a lazy one doesn't change anything. What changes is that from that point on, all the operations will benefit from query optimization.
Thank you. Do you know about Kafka Polars integrations?
No, unfortunately. It would be lovely to.
Perfect. Your example on filtering show sorting data before filtering it.
Yes.
Is it the kind of things Polars can automatically optimize? Is it better to sort after?
If you're working on a lazy data frame, these kind of operations are optimized. So don't quote me on this, but it doesn't really matter. The reason why I sorted here before doing the filtering is that I wanted to perform the rolling function, so count over. We're already having the sorting done because I was not sure. I believe that I was on the Polars Discord. It's quite active. Hope to you can go there because it's a lot of people explaining, sharing stuff, benchmarking stuff. There is no way to say as in SQL rank over order by. There is not a native way for doing that yet, as far as I know. Maybe they implemented like in yesterday's release or something like that.
Thank you. What about UDFs? Can they lazy evaluated through polars?
So polars and as much as like pandas as an apply function, but as it is with pandas, you shouldn't be using that. So you can define a custom function. I don't know, for example, you have to, I don't know, group by and then apply a function to compute, I don't know, pairwise distances and stuff like that, using a function from, I don't know, SciPy. That can be done. You won't get all the benefits from using Polar's query engine. So you can say column.expression.apply and pass a function. You can use UDFs, but it's not optimal in terms of performance. Of course, if that's the only way that you can work it out, then you can do. You can also perform a group by and create a group by context. And then basically this, if you just had raw.groupby, it will create, basically, you can use it as a context manager and then iterate over the groups, for example, then apply the function to group. But in general, it's not recommended to use apply function and UDFs. Just find a smarter way to use the existing Polar syntax if you can.
Thank you very much.
Thank you.